Another application about the law of combining gases, and the idea more than that is the Avogadro's theory, is that it doesn't matter what the sample of the gas is, it's going to occupy the same volume if it has the same temperature and pressure. And so its mass is going to be different, but its volume and number of particles is going to be the same. And so that brings us to looking at molar volume. And for two temperatures and pressures that are often used, STP and SATP, there is the number, we know what that volume is. So basically for 1 mole of a gas at STP, it occupies 22.4 liters per mole. So 1 mole of the gas will occupy 22.4 liters. At SATP, it will occupy 24.8 liters. So 1 mole of a gas will occupy 24.8 liters. Now, what's interesting about this is that, how do you remember these numbers? It's easy. This is how I remember it. 2 times 2 equals 4. 2 times 4 equals 8. That's how I remember them. All right? So again, it doesn't matter what the gas is, as long as you know that it's at STP or SATP, you know its volume. And so we can go from volume to moles or moles to volume really easily at those two conditions. So let's go through some examples and see how we set this up. So it says, what amount of oxygen gas is present in 1.2 liter sample of STP? By the way, when we say amount, we mean moles more often than not. In fact, I'm trying to change things, so if I mean mass, I say mass, I don't say amount. I don't think I've caught everything yet in my work, but usually when we say amount, we mean moles. So how do I solve this? Well, you start off by writing down the number that the question gives you, so 1.2 liters, okay? And I know that it's at STP, so I know at STP, that gas sample, doesn't matter what it is, it's going to occupy 22.4 liters. So what I want to do is write down liters in my denominator so it cancels out, moles, which is what its question's asking me on top, and then I'm going to write the number. So remember that the number always travels with the upper unit. It travels with the first unit, in this case liters. So I'm going to put 22.4 liters per 1 mole. So no number there means that it's 1. My liters cancel out. I'm left with moles. So it's 1.2 times 1 divided by 22.4. And this is 0.053571 moles. Rounded to the correct number of significant digits, 0.054 moles. So what did we just discover? So we have a sample, it says oxygen gas, but it could be any sample. It's at STP and I've got 1.2 liters of it. So that means that that sample has 0.054 moles. All right, example 2 says, what is the volume of 0.120 moles of helium at SATP? So again, start with the number that the question gives you, always. Set up your ratio, moles at the bottom, liters at the top. This time it's SATP, so I'm going to use 24.8. Remember that the number goes with the first unit. My moles cancel out, and this turns out to be 2.976 liters. So again, rounded to the correct number of significant digits, 2.98 liters. And our next example says, how many mils of nitrogen gas weighs 0.0346 grams at STP? Well, this is actually a two-step problem because I can go from mass to moles using molar mass, and then from moles to liters using either 22.4 or or 24.8, depending what I've got in the question. So I can go back and forth with that. So do you see that by being given a mass, I can use the molar mass to find moles, and then use the moles to find, and then use the moles and 22.4 in this case to find the volume. So it's a two-step problem. So here we go. I write down the number that's been given to me. I'm going to use my molar mass, and nitrogen, remember, is N2, so I need to multiply the molar mass by 2. And this turns out to be 0.012348 moles. Okay, I'm not going to round that number. I'm going to keep it unrounded. And then my second step, I'm going to start with that number. And now I'm going to use molar volume. So again, this is STP. My moles has at the bottom, my liters go at the top. And so I know that it's 22.4 liters in 1 mole. My moles cancel out. And this turns out to be 0.0277 liters. All right? Now, you can also do this in one step together. Now, if this, what I'm showing you next, doesn't make sense, then use this to help you out. But some of you might be able just to see the units, so I'm going to show you how to do this all in one step. So basically what you do is you write down the number that the question gives you. And let's see if I can do that correctly. 0.0346 grams. Again, I'm going to use the molar mass. And then what I'm going to do is I'm not going to solve. I'm actually going to go right next to my ratio. So do you see I'm left with moles? So moles has to be at the bottom, liters at the top. This is 22.4 liters in 1 mole. And so I've done it all in one step. So this is 0.0346 divided by 28.02 times 22.4, and you end up with the same answer and in just one step. And it's a little bit faster and a little less prone to error. So I hope that made sense how to use molar volume. Remember that these numbers, we only use them if a gas sample is at STP or SATP. And what it allows us to do is use basically Avogadro's theory to switch between volume and moles really relatively easy by using this conversion factor of 22.4 for STP or 24.8 for SATP.